Hello everyone. Our today's topic for A-level chemistry is Friedel graphs, alkylation and acylation. These are also the example of electrophilic substitution reactions of benzene. Basically, Friedel graphs, alkylation and acylation is the substitution of alkyl group and acyl group in the benzene ring. First of all, in this case, for alkylation, we select halogenoalkanes and then treat those halogenoalkanes with a catalyst which is acting as an acid, because these catalysts, for example aluminium chloride or iron 3 chloride, these are the substances which can gain pair of electron. These are the electron pair deficient, and those substances which are electron pair deficient, those are called as acids. Now, this also acts as a catalyst. These first of all gain electron from the halogens, from all halogens, and the electron present making covalent bond between carbon and halogen will be shifted on halogen atom. Automatically, after formulating a dative bond with halogen atoms, aluminium chloride will change into a aluminium tetrachloride with negative 1 charge. What will left behind? It will produce carbocations. This is from chloromethane, methyl carbocation is produced. From chloroethane, ethyl carbocation is produced. From 2-chloropropane, then isopropyl carbocation is produced. These are all carbocation produced. These are produced from halogenoalkanes. That's why these are called as alkyl carbocations. Now, in the similar manner, the acyl group from acid halides, whenever we treat acid halides, this is ethanoyl chloride and this is propanoyl chloride. Whenever these will be treated with aluminium chloride, after accepting pair of electron making dative covalent bond with chlorine, again produce the same species and also produce the carbocation of acyl group. Now, these carbocations are more powerful electrophile. Then these can get electron from the benzene, and then consequently a substitution reaction will start. For example, if I write down the reaction for this purpose, for example, this is benzene. If we have this carbocation, primary carbocation is there, this is a powerful electrophile. In the similar manner, it will gain electron from benzene, attack on benzene ring, gain electron, and an intermediate will be produced in this manner. For example, CH2, CH3, and with one hydrogen having positive charge on benzene ring. As we have discussed earlier, that this pi electron system of benzene cannot be remain distorted. That's why the pair of electron present in bond between carbon and hydrogen will be involved inside the benzene ring, producing the required product. Now this will become just like this. This is a bonding present. When this pair of electron will be involved into benzene ring, what will be the product? The product will be once again ethyl benzene. Ethyl benzene producing H positive. As a result, this H positive finally will react with AlCl4, producing HCl and AlCl3 once again. This AlCl3 is regenerated, which acts as a catalyst, proves to be that this is acting as a catalyst. In the similar manner, this is the substitution of alkyl group into benzene. That's why this is called as the alkylation. In the similar manner, acylation will take place whenever the carbocation of acyl group will attack on benzene. What will happen? In the similar manner, this carbocation of acyl will attack on benzene, gain electrons, and intermediate will form, and finally this arrangement will take place just like this, and positive charge will be created in the benzene ring. But this positive charge will not be maintained for a long time. That's why the carbon hydrogen pair of electron is involved into the benzene ring, maintaining its original circulation. As a result, it will produce the final product. With substitution reaction plus H positive, phenyl ethanone is produced and H positive ion is produced. This H positive ion in the similar manner as we have already discussed reacts with AlCl4 minus producing HCl plus AlCl3. The substitution of this acyl group into the benzene ring, this is called as acylation. As both of these reactions were introduced by Friedel and Graf, that's why with the name it is now a famous reaction, Friedel-Graf's alkylation and acylation. Now, there are two things involved in this case. If we draw the structure of benzene, if a monosubstituted product comes, just like methyl, just like other OH group or some other alkyl group, these are electron donating groups. So these provide electron to benzene ring and activate this benzene ring. That's why these groups are called 2,4,6 directing. It means that if these groups are already present on benzene ring, then the second incoming group will be directed at 2 or 4 position. This position, at this position, or at this position. This is position 2, this is position 4, and this is position 6. These are termed as 2,4,6 directing group. These are activating group. But as we have discussed, if there is acyl group present or nitro group present on benzene ring, just like this, these are deactivating group. Carboxyl group or aldehyde group or ketone group, whatever the case, these are deactivating group, means they can provide a passage for the removal of electron from the benzene ring. That's why these groups are termed as 3,5 directing group. 3,5 directing group. What are the 3 and 5? From this carbon, 1, 2, 3. Now, second group will be adjusted here or adjusted here. These are the positions. That's why these are termed as 3,5 directing group. Now, second point is oxidation of side chain in adenes. For example, we know that this is methane, ethane, or whatever the saturated hydrocarbon. These are not oxidized. These don't react with KMnO4 or K2Cr2O7 followed by the addition of concentrated sulfuric acid. But if these groups are attached with benzene ring, arenes, if these groups are attached with benzene ring, for example, methyl benzene is there. Now, if we react with all these, with KMnO4 in the presence of concentrated H2SO4, what will happen? Now, the oxidation of benzene will not take place, rather the oxidation of side chain will take place. Why? Because this pi-electron system involves all the electrons of the alkyl group, leaving them electron deficient. So the oxidation of these groups takes place quite easily, and only one carbon remains attached with benzene ring, which is converted into the carboxylic acid as a result. Whatever the case, wherever the alkyl groups are present, that will be oxidized, and consequently we will get the carboxyl group derivatives of benzene. Now, this reaction will give us benzoic acid and rest of water molecule or as a result of oxidation. Now, if we have more than one group attached, for example, there is also methyl group or there is ethyl group present also, and here we get, say, propyl group, CH2, and then CH3. What will happen? If we will oxidize this product, all of the alkyl group will be changed into the carboxyl group, and we will get KMnO4 on reacting with concentrated H2SO4. What will be the final product? The final product will be wherever the alkyl group is present, that will change into carboxyl group here. This will also change into carboxyl group here, and this will also change into carboxyl group here, producing carbon dioxide and water along with them. Now, this reaction can also be carried out not only by KMnO4 but also using potassium dichromate. This is also a strong oxidizing agent, and in the presence of concentrated sulfuric acid, it can easily oxidize all those side chain arenes which contains alkyl group and can be converted into the carboxyl group. Hope you understand all these concepts. Please comment, share, like and subscribe the channel.